Okay guys, today's lesson is factoring trinomials, and if we want to be really specific, we are going to be factoring quadratic trinomials. Okay, so quadratic trinomials in what's considered standard form is usually ax squared plus bx plus c, where a, b, and c can be numbers of any kind, positive, negative, decimal, fraction, whatever. But for right now, we're going to stick with, nice, pretty whole numbers and stuff. But today, notice how we're going to factor ones where a is 1. So what you're going to notice is there's not going to be a leading coefficient, except for on the next page if you've already looked, but we'll get to that in just a second. So if you remember me saying earlier whenever we were learning how to multiply, right? All this is that distributive property backwards. Okay, so let's look at number 1, for example. Here I have b squared plus 8b plus 7. Okay, so if I were to unmultiply that, I know I'm going to end up with 2 binomials. It's like multiplying 2 binomials together. Remember, we said that it's FOIL. Remember how I talked about that means first, outer, inner, last. If that's helpful, if it's not, then don't use that. So remember, like when we multiplied the first times the first, right? That gave me that first term. Well, I know if I have a b and a b, that's going to give me b squared, right? And the same thing with the last. In order to get the last, which would be this number right here, I would have to do something times something is 7. Now this one's a pretty simple one because 7 happens to be prime and I only have one choice. 1 times 7 is 7. So I know that 1 and 7, or you could put 7 and 1, I could have put them in the other order, is going to give me 7. Please notice how everything is positive in this problem, so I know that it's going to be b plus 1 and b plus 7. Okay, so here I want to show you something. If I were to multiply this back out, now this is my answer, like this is the factored form of number 1. Okay, so if I were to multiply it back out, b times b is b squared. B times 7 is 7b. 1 times b is 1b. And of course, 7 times 7 is 7. So the first part and the last part, like this one and this one, that's pretty easy. But it's the middle part that usually gets students, right? Because 7 plus 1 is obviously 8, right? But let's look at what happens whenever I have a number on the end that's not prime. Okay, so like let's look at number 6. Let's look at number 6. I'm going to do another all positive one real quick. Okay, so again, I know I'm going to have 2 binomials. And again, my b squared is going to, basically I'm taking it apart, so to speak. It's going to become a b and b, right? If I multiply that together, that's going to give me b squared. So here's the thing. 64 is absolutely not prime, right? If I thought of all the ways I could multiply and get 64, let's see if I can think of them all. 1 times 64, 2 times 32, 4 times 16, that's a 16. I don't know where that came from. That's weird. This is 16. 8 times 8, that's the last one, right? Yes? Okay, I think that's all the ways you can multiply and get 16. My point is, it's like, what do I put here? Do I put 2 and 32? Do I put the 4 and the 16? Like, what do I put? And that's where your middle term comes in. Okay, I know that whenever I do the outers and inners, that whatever these two are going to have to somehow add or subtract to get that middle term, like what happened on the first one. So I need to look at my choices here and go, okay, now which one of these is going to give me a 16? Hopefully it would be obvious that it would be the 8 and the 8, right? Because if I added 8 plus 8, that also gives me 16. So I know I'm going to have a plus 8 and a plus 8. Okay, now again, this is my answer. This is the solution. And if you're comfortable with multiplying, you can always multiply that back out to ensure that you definitely get b squared plus 16b plus 64, and you do. Okay, so I'm going to take a time out, and I would like for you to try number 10, and try number 14, and number 19. I think that's all of the adding ones, okay, that I want you to do. Okay, so those ones are just like the two that I did. Notice how everything's positive. You're going to use the factors of the last number, but they have to add up or subtract. In this case, add up, because everything's positive, to the middle number. Okay. Now, let's look at what happens with one like number 2. 3. I meant 3. Okay, so let's look at number 3. Now, I still need, it's the same idea. I know I'm going to have 2 sets of parentheses. I know I'm going to have an m and an m, right? Because m times m is m squared. Easy peasy. 90. Now, if you are great with your times tables, these are super duper easy. I won't have to make an entire list of all the ways I can multiply and get 90. I just need to think of 2 numbers that multiply to get 90 that somehow I can get a 1 with. Now, notice the difference between this problem and the last 2 that I did. You have a minus sign. So that means whenever I'm multiplying the 2 numbers together, they're going to have to equal a negative 90. So one of these is going to have to be a positive, and one of them is going to have to be a negative, right? Because whenever I do that last times last, it's going to have to give me a negative 90. And if they were both positive, that would give me a positive. And if they were both negative, that would give me a positive. So I know those signs are going to have to be different. That also means I'm going to have to subtract those 2 numbers to get a 1, right? Because that is a 1 here, instead of add them. Again, because the signs are different. So if you were to think of all the factors of 90, hopefully eventually you would get to 9 and 10, right? 9 times 10 is definitely 90. I know if I subtract 9 and 10, that gives me 1. Now I have to be careful with my placement because obviously one of them has to be positive and one's negative. And this is where you just have to think, oh, I need a positive 1. So if I put my 10 here and my 9 here, that would definitely give me a positive 1. So my answer is m plus 10 and m minus 9. By the way, that can be switched. It could be m minus 9 and m plus 10 because multiplication is commutative. But I just, like I said, you can check it. M times m is m squared. M times minus 9 would be negative 9m, right? Positive 10 times m will be plus 10m. And of course, we already discussed how 10 times negative 9 would be negative 90, and look how that definitely gives me a positive 1. So you can always check your answers on these. So let me do one more of those with plus, I'll just scoot over here and do number 4. Okay, so it's the same kind of problem. I see that I know that I'm going to have my 2 parentheses, and my n and my n. I know that my 2 numbers are going to have to multiply to equal 12, right? So I could use a 1 and a 12, a 2 and a 6, or a 3 and a 4. This time, they're going to have to equal 4, right? And notice it's a positive 4. So we know that it's going to have to be the 2 and 6, right? Those are the 2 that are going to give me a positive 4. So I know I'm going to want a positive 6 minus 2 because that gives me a positive 4. If I had switched the signs, that would give me a negative 4. So that's the solution. That's the factored form of n squared plus 4n minus 12. Okay, so all it is the distributive property backwards. So if you're looking at those ones, so 7 would be like that, and I'm looking at the ones that have a leading, and 25 would be like that. Okay, so try those 2. It's exactly like those 2 that I just did. All right, moving right along. What if let's see. Let's look at number 2. Okay, so number 2, look at it in comparison to number 4. I can see that obviously I do have 2 different signs, right? I have a plus and a minus, just like I do on number 4. But notice how they're switched. That's actually a big deal. Because if I were to do my 2 parentheses, again, my n squared is going to become an n and an n. I know that my 2 numbers have to multiply to equal 10. So it's either going to be 1 times 10 or 2 times 5. But they need to multiply to equal a positive 10, but they're going to have to add up or subtract to equal a negative 11. Right? So it's not going to be 2 and 5, right? 2 plus 5 is 7. 2 minus 5 is negative 3. So it's not going to be that. It's got to be the 1 and 10. So 1 and 10. But like I said, we know that. Well, I just wrote all over this. Ooh, hey, I didn't mean to erase all of that. There we go. It needs to be a positive 10. So I wouldn't want to put a plus and a plus here because positive 1 and positive 10 do not equal negative 11, right? What I need is a negative and a negative. Because look what happens. Again, this is my solution, just to be really clear. This is my answer. This is the factor form. Let's see why it's the factor form. If I were to multiply this out, n times n squared. N times negative 10 is negative 10 n. Negative 1 times n is negative 1 n. And then negative 1 times negative 10 is positive 10. Negative 10 minus 1 is negative 11. Okay, so you have to be careful and pay attention to where the plus and minus signs are in these problems. Okay, so let's do one more of those with a negative first. Here we go. Number 5 is a good one. I know I'm going to have an n and an n. The 2 numbers that multiply to equal 9 that add up to a negative 10 will be a negative 1 and a negative 9. Right? Negative 1 times negative 9 is positive 9. Negative 1n plus negative 9n equals negative 10n. So that's my solution. Okay, again, you could have written it as 9 minus n. N minus 9 and n minus 1. This is also a correct answer, okay? Again, multiplication is commutative as long as you have the signs with the correct numbers. All right, so number 8 is like that one. Number 9 is like that one. Number 12 is like that one. 13 is like that one. 24, 23. Okay, so all of those are like that one. All right, and finally, before we get to the ones that happen to have numbers in front, let's see, where am I at? Which ones have I done here? Ooh, I'm so sorry, I have messy notes. All right, let's look at number 11. Okay, so obviously here I have no plus signs, so I'm really going to have to think about my negatives. Really not a big deal, guys, I promise. It's not bad at all. I know that I have my 2 parentheses. I know that n squared is going to become n and n. I know that my last 2 numbers are going to have to multiply to equal a negative 56. So kind of like what happened on the second example that I did. I know that one of these is going to have to be a positive and one of them is going to have to be a negative to equal a negative number, right? The signs are going to have to be different. Excuse me. And of course, 8 times 7 is 56. And 8 times 7, 8 plus 7, or 8 minus 7, I can get a 1 out of it, but it's a negative 1, right? So, kind of like a minute ago, I just need to be careful with my placement. A positive 7 and a negative 8. That's my solution. If I were to multiply it back out, just to check, n times n is n squared, right? N times negative 8 would be negative 8n. Positive 7 times, what is that doing? positive 7 times n would be positive 7n, and 7 times negative 8 would be negative 56. Of course, negative 8 plus 7 is negative 1. Okay, so it's very similar to the second one. Again, I just have to be careful of where I put my negatives. Let's see, they don't give me too many examples of that kind, do they? 18 is literally the only other one, it looks like, other than 22, but again, we haven't gotten to, so I'm just going to go ahead and do 18 for you, just so you have another good example. Wow, we've already done 90. So we know the two numbers that it's going to multiply, of course, are 9 and 10, right? Because as we talked about a minute ago, 9 times 10 is 90. But this time it's going to be a negative 10 and a positive 9, right? Because negative 10a plus 9a is negative 1a. And negative 10 times positive 9 is a negative 90. Alright, so they did decide to throw in, if you'll notice these last few all have a leading coefficient, right? All of those other ones have a leading coefficient. All it is, so like I'm going to do number 16. Look at that. That has the greatest common factor. I can divide every single one of those by 5, right? That's the greatest common factor. So like we've done the last 2 days, I know I can take out a 5, right? And that's going to become n squared plus 2n plus 10. Not 10, that's 4. You would think I'm a math teacher. That would be 4. Is that factorable? 5 times 2, listen, it's late, so give me a second. That's not factorable. That's not factorable. Okay, let me explain why, well, I mean, it is, like, that's the answer. Well, fudge buckets. Kind of disappointed they gave me this problem. Okay, I'm just rethinking my math here. Now I know this is right, because 5 times n squared is 5n. 5 times 2 is definitely 10, yep, and then 5 times 4 is certainly 20. So I did factor it correctly. Yes, okay, so this is actually my answer. I can't go any further with this one because look at this. And this happens sometimes. I just kind of hurts my feelings a little bit. The factors of 4 are 1 times 4 and 2 times 2. There's no way I could take either of those pair and get a 2 out of it. Like, it's not possible. Neither adding nor subtracting. So I can't factor them like I've been doing with all of the rest of them. Let's see if they give me another one that not a big fan of that. Okay, let's just look at number 17. I'm trying to keep it all positives here. Okay, obviously greatest common factor is 2, right? So let's do this one. 2k squared plus 11k plus 30. Okay, so now this one I can factor because think about what the factors of 30 are. If I do 6 times 5, that's 30, right? And I know if I add 6 plus 5, that's going to give me an 11. That's what I assumed that last one was going to do. Again, not a fan. I know my 2 parentheses are going to be a k and a k. So that 2, notice how it just comes down. That is just an ornament now. And then plus 6 and plus 5. Because everything's positive. 6 plus 5 is 11. 6 times 5 is 30. So that's the solution for this one. So on all of the other ones, again, I'm totally making an assumption here because, again, number 16 was a little weird. All the ones with the numbers in front, they all have a greatest common factor, which you can take out. And then it would make it like the other ones that we did. Okay, so hopefully you've taken really good notes. If you have questions, make notes of those questions. We'll talk about those on Friday. But I'm going to leave those there for you to try, the ones that I've circled, because this is one of those things that you're really going to need to practice. So when you get a time,